Welcome to Part B, and in this part we talk about delegation. Now, normally delegation is not used by itself, it's used in conjunction with protocols. And in Swift, when we get into iOS app development, we are going to use a lot of protocols and a lot of delegation. Okay. So before we get on to delegation, let me just focus on what we spoke about in the last part, which is protocols. Protocols are fully fledged data types. You could use it anywhere. It behaves like any other data type. So you can define instances of protocols. They work like any other data type. Although they're not classes in the strict sense, because a class has its properties, it has its methods, and all of its methods have got the code written in the implementation. But the protocols are not fully fledged classes. They're just skeletons of classes. We sometimes call protocols abstract classes. They're not real classes. They're not concrete classes. They just have a skeleton around them. It's up to the classes that adopt them or adopt these protocols to write the code or to implement the code. Good, so that was protocols. Let's now get down to what this part is about. This part deals with delegation. So in English, when you delegate something, you basically get somebody else to do the work for you, okay? Or you concede something to somebody else, okay? That person being your delegate, and you are the one being the one to you delegate some work to the delegate, okay? Now in the same way, we can have delegation between two classes. So delegation allows one class or structure to concede or delegate some work or decision making to another class or structure. Or in other words, one class performing work on behalf of another class. The class you are delegating the work to reports back once the task has been complete. So if one class is delegating work to another class, the other class is called the delegate. That class does the work, and when the work gets done, the delegate reports back to the class that called it, okay, or asked it to do some work. And as I mentioned a few minutes ago, protocols can act as fully fledged data types. Okay? And in iOS and the development in Swift, we normally implement protocols and delegation together, and we call this the Delegate Protocol. Okay. Now let's take an example. So before we take the example, let me give you the concept first of what we're going to do in this example, how we're going to use delegation. Now I'm going to make a program, write a program for what we call a vending machine. Now you know with a vending machine, you put in a coin into the vending machine, all right? And once you put in the coin, if you insert the coin correctly, then the vending machine would give you the correct drink that you wanted to, whether it's a Coca-Cola or an orange drink or a lemon drink, whatever. And if no coin was inserted, then if you press the button, you would not get the drink come out. So what we're going to do is we're going to create a vending machine program, and it's going to be quite simple. Once the coin is pushed in and it's the correct cost, correct amount, it's then going to vend or give you your item or your drink. Now I have two classes. I have a cola machine class and I have a vendor class. the vendor class is going to be the delegate for my caller machine class. Okay, so the caller machine class is going to delegate some work to the vendor class. Right? Or in other words, you could say that the vendor class is the delegate of the caller machine. Okay, where the vendor class is going to do some work on behalf of the caller machine, or it's going to act on behalf of the caller machine, or the caller machine class delegates some of the work to the vendor class. Now, yes, we're going to use delegates, but we also want to use the concept of protocols. So what I'm going to do is I'm going to make a protocol called the vending machine protocol that's going to define a property. No, in this case, the vending machine protocol, yes, it's going to define a property, and it's also going to define a method, but it's not going to implement this property or method. It'll be up to the vendor class to set this property and to implement the method. So the vendor class is going to adopt this protocol called the vending machine protocol. Okay. Now, how do we make the vendor class a delegate of the caller machine class? Okay, this is how we do it. The vendor class, when an object of the vendor class is made, we create a property in caller machine class, okay, which is an object of vendor class, and we make it a property inside the caller machine class. So in other words, the property here is actually an object that points, it's a variable that points to a vendor class object. Okay? Or in other words, a vendor object of type vending machine protocol is actually a property in the caller machine class. Now, if that all sounds a bit complicated, let's take an example, and maybe that it will become clear to you how we do delegation using a protocol. So let's start off. This is what we'll do. We'll start off by creating the vendor machine protocol, and then we'll create the vendor class, which adopts the protocol, and then we'll create the caller machine class with a pointer to the vendor object, and then we'll create objects of these two classes and see and test if the classes actually work. So here I have a protocol called the vending machine protocol with the keyword protocol. It has a method called coin inserted, and it's going to be Boolean, either true or false, whether the coin was inserted or not inserted. And it's going to have one method called should vend. Okay, if a coin was inserted, whether the machine should deliver a drink to the user, or spit out a drink to the user. So it's just got one property, and it's got one method called should vend. No input parameters, one output parameter called true or false. Okay. Since it's a protocol, it doesn't have the code for it. It's up to the class that adopts this protocol to set the property and to implement the method called should vend. So here I'm creating a class, okay, called vendor. Now vendor is going to adopt the protocol called vending machine protocol, and vendor is going to be my delegate. Okay. It's going to do the work on behalf of the caller machine, so it's going to be the delegate. So the delegate will adopt this protocol. So if it's going to adopt this protocol called vending machine protocol, it has to set the property, and in this case it sets a default property of false when the coin is inserted, And it implements this method called shouldVend. Quite a simple method. If the coin is inserted, then it would give you the drink and it will return true. If the coin is not inserted, it will not give you the drink. So this is the delegate. Okay. Then I create another class, which is the colo machine class. Right, so I've done vendor class, I've done the vending machine protocol. Now I create the colo machine class, who's going to use vendor as a delegate and pass some work onto it. Okay. I create the colo machine class. Okay, now I'm doing something very special. I'm creating a property, and this property is a special property. We haven't come across this before, because this property is actually an object of the type of the vendor class. So it's going to have a pointer to an object of type of the vendor class, and it's also of type vending machine protocol. Okay, because I said to you, all protocols can act like data type. So we define an object called vendor of type vending machine protocol, and this here is going to hold a reference to the delegate, which is the vendor above. And here I'm just initializing this property. Okay, I've got an init method, and I define two functions in this class. I define an insert coin, okay, and I define a function called press caller button. Okay. Now these two functions are going to call the object and invoke the it's going to, there's two functions, insert coin and press caller button. This method is going to set the coin inserted property of the vendor, and this method is going to call or invoke the shouldVend method of the delegate, the vendor. So here the delegate's method is being called here, and here the delegate's property is being set, either true or false. And it also has another function called press orange drink button that calls the delegate's shouldVend method, and if it's true, an orange drink will be spitted out. If not, it means the coin was not inserted. It will return, you must insert a coin. Okay, so let's see what we've done so far. We've created the vending machine protocol. We've created the vendor class, which adopts this protocol. Then we created a vendor object, which points to the vendor class, which is the delegate. And this vendor object is of type vending machine protocol. Good. Now, once those protocols and classes have been created, let's test if our program works by making concrete objects, real objects, to test that these classes and the protocol actually work. Now, I have a statement here. Now, what's happening in the statement here is two things are happening. A vendor object is created of the vendor class, okay, and the address of this vendor object is sent to the colo machine class here. So the, oops, let's just go back here. Okay, so a vendor object is made of the vendor class, and that reference or that address is passed into this init method, and now colo machine knows the address of the vendor object, which is the delegate for colo machine. It knows the address of its delegate. because if it doesn't know the address of its delegate, it will not be able to invoke the delegate's methods. And here I'm creating another object called vending machine object of type caller machine. So in this statement here, two things are happening. A vendor object of type vendor class is made, and a vending machine object of caller machine class is made. And I'm sending off this address of the vendor object to the caller machine class, so that class knows where to find its delegate, which is vendor. And all I'm doing here is I'm calling this method called press caller button, insert coin, and press caller button again, and press caller button. And what's happening is that is going to the vending machine object, and the vending machine object is calling the delegate, which is the vendor, to do some of the work for it. Hope you enjoyed this part, which seems a bit complicated because we have one object being the delegate of another object. Then we also have this concept called protocols. And then one of the new things you've learned today is that one of the properties can actually be an object that it can actually be a variable that which is an object that points to another object, which is the delegate.